All right, this is the YouTube video in preparation for your win form for week 4. I'm going to talk very briefly about the form for this week, and then I'm going to show you some notes that will assist you with your graphing assignment that you're going to be doing. So if we start, you'll see that in this week's handout for win week 4, there's 6 vocabulary words you need to become familiar with: acceleration, initial velocity, final velocity, free fall acceleration, kinematics, and acceleration due to gravity. So 4 new words that deal with our new topic here, which is acceleration, the changing of an object's speed. And you can do what you did last week. You can choose to either make a poster, and this time I did make it a point to put that it has to be larger than a sheet of paper. So you can pick one of these vocabulary words, and once you have that word, it has to be in color. You need to add some pictures, input it into this Frayer model, and you can turn that poster in by Friday, please. Or you can choose to do a set of flashcards for each of the vocabulary words. That's another option. So you can do either or there. You pick your poison, pick what you want to do. Moving on, there's going to be an assignment that deals with graphing. You'll notice that for this assignment, though, it's dealing with velocity and time instead of position and time. Velocity is going to go on the y-axis, and time is going to go on the x-axis. And I'm going to show you some stuff about this in our notes that I'm going to go over here briefly. But I do want to point out it works the exact same, so you'll be making points for your x and your y values depending on what these values are. So for this first one, 1 second, 20 meters per second, the 1 second is going to be your x value, and the 20 would be your y value. And you would just plug this point in like you would in math. So you'd go across 1 and then up 20 and then put your point for this data value. Make sure that whenever you make these graphs that you label your axis. So make sure you put velocity and time there. Make sure you put the units, and that you also have a title for your graph, so you don't get points taken off for that. So make sure you have those two things labeled very clearly. Okay. Moving down here, you'll see that there are some questions. So once you've graphed it, for questions 2, 3, and 4, you actually need to go through and identify what is happening for the object. And we want to be very specific with our terminology, and I'll talk about that in the graphing section of the notes that I'm going to go over. But we want to use very consistent terminology so that everybody knows exactly what someone's talking about when they say, for example, that an object has, positive velocity, what that means. We want to be able to use those terms instead of just saying a straight line or a flat line. You want to be more specific. And then we also need you to calculate the slope for this range. So whenever we're calculating the slope of a line for a position, for a velocity versus time graph, the slope of this line is going to be equal to our acceleration. So when you're getting the slope of a line on a velocity time graph, you're really trying to find the acceleration of that object during that time interval that it was moving. Okay. So you'll graph that here on the graph paper that's attached to your homework. The next thing that's on this form is some simple acceleration problems. They're very straightforward. They just calculate acceleration if you know the final speed of an object and the initial speed, and you know how much time it takes for it to change its speed, you can find the acceleration. And we are going to be using the guess method, so it's going to be very important that you identify all the important things. So like here in problem 2, problem 1 is already done for you, so I'll start with problem 2, just to give you a little bonus for watching the video. A skater increases her velocity from 2 meters per second to 10 meters per second in 3 seconds. So that's our given information. They ask us what is the acceleration. Well, that's going to be our unknown, what we're looking for, and that's A for acceleration. This first velocity, the one that you start at, is your initial velocity, your beginning speed, the speed that you start with, okay? So we're going to put VI for initial velocity. And then this 10 meters per second is our final velocity, so we'll put VF. And this 3 seconds is a time, so that's going to be our time. We're going to take the 2 meters per second, the 10 meters per second, and the 3 seconds, and we're going to plug them into this equation up here for acceleration. So we're going to use that acceleration equation as our equation for this problem. We'll divide it by time. When you plug these numbers into the equation, it'll look like this. Acceleration equals 10 meters per second minus 2 meters per second. And then we're going to divide all of that by the time, which is 3 seconds. Okay, and then what you're going to do here is just simple simplification of the problem. So 10 minus 2 is 8. 8 divided by 3 will be your value for acceleration. And if we pull up a calculator here, 8 just waiting for it to switch gears here. Okay, so 8 divided by 3, let me get back to it, is 2.6 repeating. So that would be your answer for number 2. It would be 2.6 repeating. All these problems are done the exact same way. Just make sure that you show all the given, the unknown, the equation, substitution for each problem. When you're done with the 6 problems there, you'll have to finish the last 2 sections, the internalized section. Y'all are doing a really good job with this. A lot of people are doing these 3 questions or the questions that are in this section very well. But a lot of you are still not finishing the nurture section. This takes off an automatic 30 points from your win form. So make sure that you do this section. You just have to give it to your parent or a brother or sister, somebody at home, and they just have to put who they are. They have to talk about whether they feel like you understood the information and whether you mastered it. So make sure that they finish this section. It's very important. Okay. Moving on to some of the stuff for the graphing assignment, the very first one, I wanted to go through some notes that'll help you understand a little bit more about what kind of terminology you should be using when you're identifying what's going on with the objects. And we're going to begin here. Again, we're going to be analyzing velocity versus time graphs. These are not position versus time graphs, so we're going to talk about them differently. On a velocity versus time graph, again, we put our velocity on the y-axis and we put our time on the x-axis. And you can see here that there are positive values for velocity, and then below 0, there are negative values for velocity down here. Okay, so positive and negative velocity. A positive velocity could be a line that's going up or down. As long as it's above 0, that means it's positive velocity. Okay, so it's positive, it's above 0. Negative velocity would be whenever you have something that's down here, it's below 0. Now, you'll remember that we talked about the fact that with our positive and negative values, that's referring to direction. So anything to the right or up will be positive, anything to the left or down will be negative. So when we talk about negative velocities, we're just referring to the direction. These are not slower speeds, negative 6 meters per second and 6 meters per second. If we are comparing them, they're just going different directions. They're not actually going different speeds. They're both going the same speed, just different directions. So in this problem, looking at this, these values that are above 0, that just means that the object is moving to the right or forward, and the blue lines here represent maybe an object that was moving backwards to the left, okay? So that's positive and negative velocity. For a constant velocity is going to represent, again, velocity on the y-axis, time on the x. Constant velocity means that you're going to have a flat horizontal line. So this would be an example of a constant velocity of positive 4 meters per second. It's constant because it does not change its speed. So it's going to be this horizontal line across the graph surface. You can also have a constant negative velocity, but it would just be down here. But it's going to be characterized by this flat horizontal line. If we look over here at an object that's speeding up or slowing down, let me just put in our axis. So if an object is speeding up, we can have objects that are speeding up or slowing down in the positive direction, away from 0, or you can have objects that are speeding up or slowing down in the negative direction, going backwards, right? Remember, positive is forwards, negative is backwards. It's just dealing with direction. So we have to account for those different values. So if we're speeding up and we're moving away from where we started in the positive direction, this would be an example of an object that was speeding up. You can see that it changed its speed from 1 meter per second up to 6 meters per second. So that would be speeding up. and it's moving away from 0 to show us that. It's also moving away from where we started because it's positive. Over here, you can also have an object that's slowing down. So let's say it's going down in speed. So this is an object that's slowing down, but it's still moving away from where you started or away from the origin. If you look at an object that is speeding up and slowing down, that's going backwards, that would look like this. So this is speeding up going backwards, and this is slowing down going backwards. Speeding up going backwards, even though it's opposite of this one, we know it's speeding up because you can see the velocity is going from -1 to -6, which means it got faster. It's just going backwards, so it's going to be down. And this one, it's going from -6 closer to 0, so it's going to be slowing down. Okay, so this is speeding up and slowing down for a positive direction, which is away from where you started. This is speeding up and slowing down in a negative direction. Okay, and then we're going to also have to talk about constant acceleration. A constant acceleration is going to be an acceleration. We talked about constant velocity. Remember, constant velocity is a flat line. Constant acceleration means you're going to have a straight line, but it's going to be with a certain slope. So if I drew this line here, for example, you can see that it's going a constant acceleration because this line, the slope of this line, actually represents the acceleration on a velocity time graph. So the fact that it's straight means that it's a constant acceleration. If we had had something like this one, this dotted one, you can see that that is curved. So initially the acceleration was the slope of this was very low, but then you can see that the slope changed to be more dramatic. So the fact that this is curved shows us that we actually had a changing, this dotted one here is a changing acceleration. So the terms that I described here, constant velocity, speeding up as positive acceleration and negative acceleration, and then constant acceleration. These are all terms that you'll want to talk about whenever you're describing the graphs in your homework. It's very important that we all use the same terminology so that when we take a test and we see on there that it says that an object had a positive velocity and positive acceleration, you'll know what that means, and you'll be able to identify it in the graph. So that concludes this week 4 recording for your YouTube. If you're taking advantage of these, it'd be extremely helpful for you.